All right, that should get kicked off in the background, so I'm just going to get started now. There we are, lovely. Okay, so as Paul just mentioned, the idea behind this workshop, and thank you, Paul, for approaching me to do this, is just really a general introduction to cloud computing. This isn't going to be super technical. I guess I just want to impart some of the skills and knowledge that I've learned at Microsoft onto you here, and hopefully just get you a bit interested into the cloud in general and some of the capabilities around cloud in general, but also Azure. I will also mention that I'm coming here as an individual and not like a representative of Microsoft, so just keep that in mind. But without further ado, I'll just jump in. And any questions, feel free to chuck them in the chat and we'll get one of the moderators to call them out as they crop up. In terms of what we're doing here, though, just quickly start off by covering what cloud computing actually is, the ways that sort of I like to think about it and talk to customers about it, and then go into a bit more specifically into Azure and actually show you an example of what Azure actually looks like, Azure being the cloud offering or the cloud services that Microsoft provides. And I'll run through a machine learning example for that for you as well, because it's my field that I'm most passionate about, and I think it's one that everyone sort of has a bit of curiosity around. So I'll show that to you and give you a bit of hands-on experience with that. I'll close off very briefly as well with just sort of what some next potential steps actually are in terms of certifications and future skills growth related to cloud and cloud computing in general, and then close off with the Q&A. Again, any questions throughout the day, feel free to chime in. I'm very sort of easygoing when it comes to presenting. So yeah, just chime in whenever you need. Otherwise, hopefully we'll have a sort of a good chunk of time towards the end for this actual Q&A portion. I have sort of already done the introduction for me, but I will just say in terms of housekeeping as well, stay on mute throughout sort of the presentation unless you have a question, and just make sure you're going on mute when you need to. Questions in the chat. Otherwise, there is also the little hand raise feature that you might have seen. And again, if there's anything like that comes up, the moderators, I'm sure will call that out to me and I can hopefully address any of your questions. But let's jump straight into what cloud actually is. So cloud is one of those, I guess, interesting things where, especially coming from a machine learning background and working in machine learning, that is very overhyped, I will say. So there's at times a bit of confusion around what the cloud actually is. And you see a lot of non-technical folks quite often saying, oh, it's in the cloud, without actually fully understanding what the cloud actually is. To explain what we mean by cloud, though, one idea that I've loved around it is actually relating it to sort of utilities and sort of the evolution of utilities over time. If we imagine something historically like water as an example, each family back in the way old days sort of thing would have to have a well on their farm or something like that to be able to access water, or even something like electricity, where if you've got a light switch at home and you turn that light switch on, you know it's just simply going to work. Even though you don't specifically own the infrastructure related to turning on that light switch or turning on a tap in the bathroom or something like that, you know that the water's still going to come. And this is really what cloud actually is. Cloud is the idea of, the best way that I like to think about it, is passing off some of the burden related to infrastructure to some other provider, and then you just have to access those services as you need to use them. If I go back to the example I was talking just sort of a little bit about, with water, historically we'd have individuals and families would have to own their own wells where they'd actually have to get their own water. That is, they had to own some kind of infrastructure to actually get access to water to drink and do their plants and laundry and so on. But over time, what we see is that infrastructure has sort of been taken away, or not necessarily taken away, has moved away from the individual, from the consumer, to an actual utilities company. And now we just rely on that utilities company to provide those services and those utilities to us, and we just have to pay for what we need to use. And this is exactly what cloud computing is. If we imagine sort of historically, for organizations, for customers, for individuals to be able to use computers, they would have to have the hardware. If you imagine, if I'm a small business and I wanted to have a SQL database that stored all of my customer information, I'd have to have some kind of machine, some kind of hardware, some kind of infrastructure that would store and run that database. The idea behind cloud, though, is instead of having to worry about the actual individual, the consumer, the customer having that infrastructure, someone else worries about it. We host their database, we host their software, the stuff they need, and then they just access it through the internet. So it's, again, the way I like to think about cloud is sort of taking away the burden of infrastructure. So actually just the straight up upfront costs of buying infrastructure, of maintaining it, of keeping it up to date, and passing it off to someone else and then just using what we need. If we break down what this actually means sort of in an actual literal standard definition, this is actually from the International Standards Organization. Cloud computing is a paradigm for enabling network access to a scalable and elastic pool of shareable physical or virtual resources with self-service provisioning and administration on demand. What this means is exactly what I just said. We've got all of this infrastructure that we're now passing off to someone like Google, someone like Microsoft, someone like Amazon through Azure, through Google Cloud, or through AWS. You go into the actual portal for that specific cloud offering, you provision the services that you actually need, and then everything is done at the data center level that's owned by those actual owned by those actual cloud providers like Microsoft, and then you just have to access all of that sort of capability directly through the internet instead. So it's really, really powerful, and it has absolutely sort of transformed the way that all of the large organizations are actually working. If I think sort of specifically in terms of Microsoft, while when you think about Microsoft, the first thing you think of would be something like Windows or something like Office 365 or Xbox. In fact, the lion's share of sort of all of the profits that most major organizations actually have now, most major technology corporations actually make, is from the cloud. With mainly the three main ones sort of being AWS, Google Cloud, and then finally Azure, which is our Microsoft offering. And it's a really, really important skill to have, especially as sort of new upcoming technical experts when it comes to technology. Cloud is where it's at. And I'll talk a little bit more about it, where it's actually going in the future. But it's a really important skill that I strongly encourage all of you to get comfortable with, to have a bit of a play around with, and just get familiar with it, because it's a fantastic skill, especially from sort of a marketing career perspective. It's a fantastic skill to have, and one that is in high demand at the moment. So cloud's exciting. We love cloud. When we talk about cloud, though, there's different types of cloud computing, actually. So on the left, we've got what we call the service models. And I'll break these down a little bit more in the next couple of slides. But the service models might have been the things that you might have heard about before. The idea behind service models would be something like the infrastructure as a service, platform as a service, and software as a service. What these three actually mean is sort of how much of the control around the actual infrastructure we give to Amazon, to Microsoft, to Google, versus how much we actually take on and control ourselves. And those three I'll break down in the next slide. But I'll just dwell quickly now in terms of deployment models. Remember, when we talk about the cloud, not all of the clouds are going to be the same, and not one type of cloud computing, whatever that actually is going to be suitable for everyone. The most common type of cloud that you'll actually come across would be sort of a public cloud, which would just be if you went out on your own, you made your own Azure account, and you played around with some of the services on Azure, you'd be working on a public cloud. So these are clouds that are owned and operated by a third-party cloud service provider, so Microsoft Azure, AWS, or Google Cloud. And then those organizations deliver the computing resources such as servers or compute or storage over the internet to the actual sort of customer or to the user. So with public cloud, all of the hardware, the software, and supporting infrastructure is owned and managed by the actual cloud provider, and then you just access those services through a simple web browser. We know, though, that sort of in some governance situations, as an example, from sort of a policy perspective, we can't always have some of that data in a public cloud, even though it is sort of secure and it's sort of guaranteed by all of these SLAs and so on. Sometimes we do have customers where they actually have to have a private cloud. So this is a cloud where the computing and the resources are used exclusively by a single business or organization. So it can be physically located on the actual organization or company or customer, whatever you want to call them, on site with them, or it can be sort of in an external data center. But the important thing with a private cloud is that that infrastructure is owned and only used by that one individual organization. So a common example about when we might see a private cloud would be something like government, or when there's sort of in defense as an example, where there's really, really sensitive information that we cannot risk being leaked. So we have it on a private cloud where that infrastructure is only owned by that specific organization, but it's managed typically by a third party sometimes. And then you move into hybrid cloud, which is a bit of a combination between both of them. So some of the infrastructure is owned by an organization versus some of it being owned by a public third-party organization as well. So an example of this would be something like Azure Stack, which some of you might have heard of, which is basically a version of Azure that our customers can actually have on site with them and use all of the Azure capabilities. So that's in terms of deployment models. I'll touch now on service models, and you might have seen this slide before, and it's one that I absolutely love because it sort of breaks down what I mean when I say management of the actual infrastructure itself. If we have a look at the example on the left here, the far left, this is sort of the traditional approach where everything here is blue, which means sort of you manage it, you the customer manage it. So we've got no cloud computing going on here. Everything from the networking, storage, servers, all the way up to the actual applications that we end up sort of using ourselves or giving to our customers is owned and run and managed entirely by the organization or the customer itself. And that's expensive because you've got to keep everything up to date in terms of sort of updates for servers and so on. You've got to manage all of the applications yourself in terms of software and bugs. You've got to have the physical hardware and server racks on site at your organization to actually to run this stuff. And that's expensive. And a lot of the times there's the upfront, there's both sort of the management costs associated with it, but also the upfront costs of actually having to purchase an entire server rack and have it set up. And then you've got to pay for employees who can actually continually manage that as well. So it's expensive to actually own and run all of this infrastructure yourself. When we start to move into the cloud, though, as we move along to the right, you'll see we have first up IaaS. So IaaS stands for Infrastructure as a Service, and this is really the most basic category of cloud computing services that we have. The idea behind this is that things like networking, storage, servers, and then also virtualization, which is basically the idea of VMs, are able to be rented out to specific customers. So the vendor actually manages them. So the vendor being someone like Microsoft or someone like Google or someone like Amazon. Then the customer just goes through into the portal and says, hey, I need this much storage. This is the data I want to store. I'm going to upload that data into the cloud, into the internet. And it's all stored inside of that data center. You just pay for what you need. You only have to pay as you go based on what sort of compute resources you actually end up using. And in terms of the infrastructure sort of side of this, remember, they don't actually have to own or manage or update any hardware here. But they still have a lot of control over their sort of middleware, their runtime, the data itself, and then also the applications that they're dealing with. Where things start to get a bit more confusing, and I find where a lot of sort of university students get a bit tripped up, is around PaaS. PaaS stands for Platform as a Service. So whereas IaaS, we're sort of just dedicating, Microsoft takes over sort of the infrastructure side of things. With PaaS and PaaS-related services, the idea behind PaaS is we're offering a platform instead. So Microsoft or Google or Amazon will also then, on top of the infrastructure side of things, start to take control a bit more into the software side of things. So the operating system, the middleware, and then also the runtime environment. So PaaS is all about giving organizations and our customers a platform wherein they can actually on demand have an environment where they are able to develop, test, deliver, and manage their own software applications. Remember here with PaaS that they've still got control over the applications and the data itself, but we're just offering them a platform to actually create these applications themselves. Good example about where PaaS is actually used specifically in Azure would be something like Azure Databricks, which is a big data PaaS solution that allows our customers to go on there, and it's built on top of Spark, and it's sort of an additional layer on top of that, a platform on top of that that makes development of these big data solutions much, much easier, as that's a really difficult field to get into. And then it sort of ties in together with a whole bunch of DevOps and integration with other Azure services. But on that Databricks platform, it's just a sort of development environment where they can go in, create their own code, create their own applications. The last one we move on to is what we call SaaS. SaaS standing for Software as a Service. And you'll see here SaaS is basically the complete opposite of a no cloud computing example. So the vendor, Amazon, Google, Microsoft, the cloud service provider, manages everything, including the actual software itself. So this is typically stuff that exists where customers can just directly connect up to this piece of software, and everything's already pre-configured for them. You can typically do some kind of customization around it if needed. On demand, they can access this software over the internet and do what they need to do with it. So an example of something like this on Azure at least would be something like cognitive services. So cognitive services are these predefined machine learning models for common use cases that customers can easily sort of connect up to and use for their specific situations. Remember, with SaaS though, we are taking away that control from the customer or from the user around the software itself. So Microsoft is the person or the organization that actually deals with the software and the data itself, and then the customer just has to connect up to it and do what they need to do with it. I've sort of broken this down a bit more from the Azure perspective, but I'll go through in terms of sort of some of the other service providers as well. If we go through something like IaaS would again be something like basic compute or network or storage related resources. So Amazon EC2 or VMware vCloud for those of you who worked with it, something like blob storage on Azure as well. If we move up into something like PaaS, we've got an example for something like Google App Engine or Salesforce, Windows on Azure as an example, or Databricks, the example I went through earlier. And then finally, the sort of highest level one around SaaS, where the provider controls everything, it would be something like Google Apps or Microsoft Office 365. So Word really is an example of a SaaS offering there. Microsoft controls all of the software. You just have to connect up to it through a web browser or through the actual application and use what you need to in there. Good time. Remember when we were talking about cloud though and IT and computing in general, somewhere along the line we have to have something that allows us to compute. Because we're dependent on this compute power to actually do something. The two main sort of benefits or services we have in any kind of cloud solution, first one is all around compute, and I'll go through these examples, and then also storage. Storage is obvious, so I'm not really going to dwell on it too much. We can store stuff on the cloud is basically the idea there. But I will break down what we say when we mean compute though, because it is quite interesting. Remember, the difference here is that to be able to use this compute, you don't actually have to buy any of the hardware or install any of the operating system stuff. It's all managed for us. And these are just the three common examples around some of the compute services that most cloud offerings actually have. So I'll start off on the far left. The most obvious one that we come across would be something like a VM. I'm sure some of you have worked with VMs before. The idea behind a VM, though, is that it's really a virtual desktop that we can actually work from. So quite often with cloud offerings, you can actually sort of provision being sort of getting access to and creating a virtual machine, and then you can actually log directly into that virtual machine, and it's just another computer that you can actually configure and do what you need to do with it. So as an example, you can choose what kind of operating system you're running on, whether it be Linux or whether it be Windows. Then you can configure any kind of applications associated with that. So a common thing we actually end up doing is putting something like SQL Server on a virtual machine and then running that virtual machine inside of Azure. If we break things down a little bit more, though, we come across something a bit more interesting, which is something like containers. So the idea behind containers is, unlike a virtual machine where we have to have sort of operating system and a whole bunch of software pre-installed in the virtual machine to be able to run it and use it, containers are just the bare bones sort of piece of logical, I guess, software that we actually need to do or run some kind of application or piece of software. They run on top of what we call a container engine. So some of you may have heard of something like Kubernetes before. And containers are really, really exciting, especially in some of the areas that I work in with machine learning. So quite often with containers, what we end up doing is we train our machine learning models. We get them sort of all to the fidelity that we actually need to. But then to actually move and give users access to our machine learning models, we actually containerize them. And inside those containers, what we actually include is all of the libraries that we need to run that specific bit of Python code, for an example. So it could be something like TensorFlow and NumPy or something like that. And then all of the bare bones sort of OS information that we need. And the benefit here is that it's a really small, compact chunk of data or piece of software that actually allows us to run an application or run something inside of it and move around easily. And they're really, really powerful. Lots and lots of use cases with containers. So definitely recommend checking them out if you haven't had to play around with them before. The final example of compute that we come across as well could be something like a serverless example. And so when we say serverless, the idea behind it is that it allows us to run application code without actually creating, configuring, or maintaining a server. So the application is broken down really into separate functions that run when we trigger some kind of action. So really, when we say function, a lot of the times we literally do just mean a function, as in one piece of function code, one chunk of code, as an example. An example of where we use serverless computing, specifically in cloud, if we've got a specific maybe database that we're trying to keep track of how much usage it's actually getting, if it goes over a certain sort of threshold, then we can actually make it so we're able to run a function that maybe will alert an engineer and say to them, hey, this server's getting a lot of traffic come to it at the moment, someone needs to investigate this. And it could just be something as simple as sending an email. There's just a very small function that can be triggered based on some action as an example of serverless computing as well. I'll jump now into sort of Microsoft Azure as well. So Azure is Microsoft's sort of set of cloud services that we sort of give to our customers and let them have a play around with. And what I'll do actually is I'll jump actually directly into Azure and show you what it actually looks like for those of you who haven't had a play around with it before. I'll go this one here. Okay. So this is what Azure actually looks like. If you want to have a play around with Azure as well, you can actually get a free subscription. You just have to create an account, log in, sign up for a free trial. I think you have to put your credit card details in there or Visa cards in there. It doesn't charge it, and then you get, I think, a couple of $100 just to play around with for free. But this is what it looks like. And if I go up to here, you can see if I search for something like machine learning, each of these individual things here, or just machine in general, are some of the services that we actually provide on Azure for customers to actually use. And so machine learning, the workspace is what I'll go through. You can see here we've got virtual machines. We've got SQL servers on virtual machines you can run. If I go to something like cognitive services was the other one that I went through, we've got that there. And it's absolutely insane, especially as a recent grad myself, how many capabilities are actually built just directly into Azure in terms of the services that are out there. You could spend literally an entire career learning this stuff. And I mean, I've started doing it. But it's really quite mind-blowing, and I strongly encourage each of you to sort of jump on here, get a free subscription going, and just have a play around, because you can do some really exciting stuff. What I'll do though is I'll jump over here to the machine learning workspace, and what I've done here is I've provisioned this workspace. The Azure Machine Learning is a PaaS offering, so it's a platform for development. And if I click here on Launch Now, you'll see it'll actually take me to a separate page. And then on here, I'm able to work within this workspace to do machine learning. Behind the scenes, there's a whole bunch of other resources that are actually provisioned. So there's some some storage that's provisioned. There's some actual compute that's provisioned. There's some application endpoint related information that's provisioned. But what I want to show you today, just as a sort of cool visual example, is the machine learning designer. So one really great thing about Azure and machine learning at Microsoft in general that I've really responded well to is this idea around democratizing AI. So making AI and machine learning accessible to anyone, even if they don't have this real deep technical knowledge. And this is what it actually looks like. We call this the machine learning designer. And it's basically an example of really an end-to-end machine learning experiment. Oh, if I can scroll with a touchpad. Using just these drag and drop modules, and you join everything together as you need. And I've already run it, so you don't have to wait for it to finish running. But everything's all gone here. So you can see here, if I right click on here, I can actually visualize what my raw data actually looks like. And you can break that down a little bit more. It'll automatically give you a whole bunch of information here. What I'm then doing is selecting the columns that I want to use within my experiment. I'm cleaning some of my data to get rid of some of the missing rows in there. I'm splitting my data up into my training test and my test set. And then I'm actually training two different models. So here I've got a boosted decision tree for regression and then a decision forest for regression. I go through and train these models, and all of this is being done in the cloud. None of this is being done on my local machine. If it was being done on my local machine, it would take quite a while, but because I'm using sort of compute instances that are specifically designed for machine learning, this went through relatively quickly. So I'm training my model, I'm seeing what my results actually were, and if I right click on here, I can then compare the results of those two separate models that I actually end up provisioning. I can see I get all of my error metrics printed out as well. Or I can break things down a bit more and actually have a look at some of the scored data set results there as well. But I mean, historically, and you can see here, this is the ground truth versus what we actually ended up predicting. Oops. And you can see we get relatively close, so it's quite good. And this was just an example one that I ended up pulling up. This wasn't one I made myself. Super easy to have a play around with. So it's just really cool, I think, that you can do this. You can jump in here, run all of this, not even on your local machine, all up in the cloud, and especially from the perspective of machine learning, where you needed to have sort of GPUs and quite sort of beefy hardware. The fact you can do this without even having to write code yourself, I think just is a really fantastic example of some of the capabilities of the cloud, about how we can democratize AI in general. Yeah, so jump on here, have a play around. It's really fantastic, and you can write code and everything like that as well if you want. And this is just one of the services that we have out there. There's hundreds. It's absolutely insane some of the stuff we have out there. And then you join all of the services together. It's a really exciting sort of field to be in. And even if it isn't specifically Azure, I strongly recommend each of you sort of go out when you get some time, maybe after exams, and have a play around. See what you can do. See if you can break something, because it's just, yeah, it's really fabulous. I'll just go back to presenter view. So I'll break now. Why do we actually need the cloud though? I spoke a little bit about sort of the cost perspective, and really that's one of the main driving forces around adoption of cloud is specifically related to costs. Remember, with cloud, we actually just pay based on what we actually use or consume. So there's no upfront infrastructure costs. There's no need for you to actually purchase or manage any of the infrastructure that you might not even be using to the fullest you actually need. You only have to pay for additional resources when they need it, and when you don't need resources, you don't actually have to use them. So when I say it's a pay-as-you-go model, if I relate that back to the machine learning designer example, I'm only going to be paying for that when I'm actually running experiments. If I'm not running experiments, it's not costing me anything. But if I'm running hundreds and hundreds of experiments, it will cost me something, but it's still typically going to be cheaper than actually having to buy your own GPUs and do this own distributed training and implementation yourself. Touching on that idea of sort of distributed as well is the idea that cloud is scalable. One really fantastic thing with cloud is that you can increase or decrease the amount of resources you actually need based on the demand or the workload that we're dealing with. So you may have heard of vertical and horizontal scaling. Vertical scaling is this idea of scaling up. So if I'm working on my local machine running some code and it's running really, really slowly and I want to speed it up, what are my options? I can either sort of optimize my code, but let's pretend it's optimized as much as possible, or I can vertically scale up. And vertically scale up basically just means improve how good my actual one machine is. So buy a more expensive CPU or buy a more expensive GPU. Or add more memory as an example. So that's vertical scaling, and we can do that within cloud. The other example is horizontal scaling, which is a bit more difficult to do. Horizontal scaling, rather than just increasing sort of the amount of resources that we give to one specific sort of compute instance, we create more and more compute instances sort of horizontally alongside one another, and then distribute whatever the workload is across all of those. And do some sort of logic behind the scenes, which thankfully a lot of Azure does automatically. And it will
I think you're muted. You just went on mute for a sec.
Oh yeah, no, good. When did I go on mute? Did you get horizontal scaling?
Yeah, we started talking about
Okay,
horizontal.
good. Sorry, I think I bumped my mic. So yeah, horizontal scaling is this idea of scaling out where we have multiple compute instances alongside one another that typically aren't going to be very powerful, but this distributed idea allows us to horizontally scale out and work through really hard workloads quite easily if we need. Related again to the idea of scaling is this idea of elasticity. So elasticity, we can actually scale based on what the demand actually is. So while you might think sort of historically, if I wanted to run some really expensive code, I'd go and buy a new CPU. Great, then I'm stuck with that CPU. And maybe I won't ever run code that's that sort of resource expensive ever again. With cloud, though, because we don't own the infrastructure, we can just optimize what actual compute instances we're using based on the workload itself. And we can actually dynamically scale this up and down based on how much traffic is coming to our server or to our application or to our software in general. And from a cost minimization perspective, this is really, really powerful as well, because if you've got a lot of demand, you want to be able to sort of address that demand as quickly as possible. But if you don't have much demand, then you scale all the way down to the minimum you possibly can, and you're saving money there as well. The idea of currency as well, so it's current. We deal with the infrastructure side sort of at minimum, so you don't have to worry about keeping your servers up to date. And then as we move into PaaS and SaaS, again, you don't have to worry about keeping all of that stuff up to date, your software and also your infrastructure. It's also reliable, and this is really, really important when you move into sort of enterprise solutions, especially something like banks, where you might have multiple failovers for servers or for individual services. Especially when you're, and this is that idea of redundancy, which you may have heard of, where if one component fails, a backup component is going to take its place and sort of instantly fulfill whatever the need of that service is until it's back up and running again. It's also reliable sort of from this perspective of just sort of service level agreements. And if you go in and actually have a look at them, it's quite confronting when you first do it, because it's just a lot of nines, as in we've got an uptime of like 99.99999, lots and lots of 9%. So you know you're going to have very, very minimal sort of downtime in terms of the actual services you're using. The idea of global as well, as we move into, again, enterprise customers and enterprise solutions where we have sort of global customer bases, we need to have global services that we can use anywhere. So you can actually replicate your services across different data centers, and I'll talk about that in just a little bit. And then based on that, also meet some of the, based on the specific regions you're in, meet some of the data residency and compliance laws or governance sort of necessities that actually exist in sort of certain jurisdictions, as an example. And then finally, secure. So I'm not going to dwell too much on security, but cloud is really, really secure because these organizations have the money to be able to back it up with security. And again, that ties into the SLAs there as well. In terms of where the cloud actually is, though, when we say something like, if I want to run an application in the cloud isn't some nebulous sort of concept. I mean, it is. In reality, though, when we say running an application or provisioning something on the cloud, we're actually running it, the application and the data, hosting it in the cloud at a specific data center. So these data centers are just a facility that houses all of these like rows and rows and rows of server stacks and compute sort of capabilities, and any sort of networking and storage systems or related components, all within these data centers. If you ever get the opportunity to go to a data center, I strongly encourage it. It's an absolutely fascinating experience. Very cold, so bring a jumper because they have to keep it at very, very low temperatures for sort of safety reasons and electricity costs. But these data centers are really what the cloud actually is. If we have a look at what the data centers around Azure actually look like, this is actually what our data centers are, where they actually are located. Some of them, at least, some of them we can't actually say. And if you go down specifically to Australia, you'll see we've actually got quite a few. So we've got Australia East, Australia Central, and then Australia Southeast as well. So we have these data centers in Australia. We've got two in Canberra. One of them you can actually tour, I believe. where you can actually provision these resources, use these resources as you need. And obviously, the closer the data centers are to you, there's lower latency associated with it, which means response times are going to be quicker. But you can see here, it's global scale. This is touching every single continent, every single country in the world is interacting with cloud. And it really is sort of the future of computing. As I mentioned earlier, this is where all of the large sort of international tech corporations are actually going. Even the domestic ones are doing this as well. So it's a fantastic skill to know, and it's marketable. You can see here, if you want to move overseas, there's a data center somewhere I'm sure that you could find to work in, if sort of the data engineering side is where you want to go. But there's customers near all of these data centers as well. Each of them sort of, I'm sure, are eager to hire young, bright minds like all of you as well. I will just also here touch on what's the future of cloud. If I think about it from my perspective and again, kind of the Microsoft perspective, the future of cloud is all around this idea of what we call the intelligent cloud and the intelligent edge. Some of you might have heard of what we call IoT, which stands for Internet of Things. And the idea with Internet of Things is that our devices over time, our televisions, our refrigerators, our microwaves, our shops that we go to, are getting more and more sort of smart, and they're getting more and more technology and sensors put into them. There's all of this data coming in, all of this telemetry data, customer data, this clickstream data, everything is coming in. And that's too much data to actually be able to handle sort of at an individual sort of organizational level. And so we need the cloud for that. And the idea of intelligent cloud is that all of this data is coming in from the edge, and we're pouring it directly into the cloud. And then on the cloud is where we do all of our compute now, where we do our fun things like advanced analytics and AI, where we store all of our data, where we transform our data, where we clean it, where we do the actual sort of the software side of things that you might have experienced so far. One thing that's quite interesting as well with intelligent edge is that the key thing we care about now is sort of reducing latency. Anyone can connect up to the cloud. Most organizations actually do have a presence on the cloud in some form, whether they know it or not now, including you. One thing that's actually quite interesting that's happening is, obviously, there's going to be some latency associated with sending data from sort of the edge at your mobile phone or from your TV or something like that up into the cloud and then doing something with it and then getting it back. But what we're starting to see now is sometimes that latency we want to reduce as much as possible. So we're starting to see some of that intelligence actually bleed over into our devices, and we call this the idea of edge, where we have sort of edge computing, where some of this sort of intelligence and these capabilities are being put directly onto the devices, and we're dealing with that data as it comes in, sort of live as it comes streaming into the device itself. We can transform it and then send it up into the cloud for some of these larger, more sort of batch big data examples of use cases. Really, really strongly recommend getting familiar with this idea of intelligent cloud as well. We're sort of the generation that AI is really starting to become normal for, I guess, especially as sort of as IT professionals. So this is a great opportunity for all of you to lean in. One reason I sort of lent into AI specifically was because I knew I'd never be able to be a SQL Server expert because there's people with 30 years experience over me. But AI is something that's new to our generation. And I think that gives us an advantage because we are sort of on equal footing with everyone else. So just, I guess, a bit of brain candy for you there. And it's something that I think everyone should start to get familiar with, is this idea of, to a lesser extent, IoT, but mainly around AI and sort of intelligence, because it's really where things are going, whether we like it or not. Yeah, I'll quickly touch here as well on what can you do to learn more. When you go into industry, you'll start to realize that certifications are unfortunately important. So how can you learn more about Azure and cloud in general? Obviously, all of the Google and Amazon and every other cloud provider obviously will have their own things, but I'm going to plug the Microsoft certifications here. If you want to go in and actually get something that you can put on your CV or your resume that shows that you know what you're talking about when it comes to the cloud, you need to have a certification for that. It shows your customers, it shows organizations that you have proven that you're an expert, or you know what you're talking about, as I mentioned. So Microsoft, we have a whole range of sort of certifications, both related to cloud and not related to cloud. If you just type into Bing, not Google, Microsoft certifications, and have a search, this page will come up for you. So here they quite nicely break it down sort of into developer, administrator, architecture, data scientist, and AI engineer are sort of where I mainly focus. But then also a couple of other things around sort of DevOps and security and so on. Have a look into here, have an investigation. They do cost quite a bit of money to actually do these certifications. But when you actually go into industry, you might see some examples where the organization will actually pay for you to take these certifications. Or sometimes every now and again at university, you might actually see some situations where you do have the opportunity to do these certifications for free if you've sort of got a sponsored program going on at the uni. So keep a close eye out keep a close eye out for those things. Where I'd suggest you start off though would be sort of the ground level Azure certificate, which is Azure Fundamentals. So you do have to take an exam for this. It's called AZ900. It's sort of the base level around Azure, the fundamentals for Azure. This is a really good place to start. Even if you don't want to take do this exam and go through this certification process, and if you actually go into this website and again just type in Azure Fundamentals and you'll find it at the top of the page. All of the certifications actually have associated learning tracks that you can go through that include videos and labs you can work through, as well as sort of some quizzes. So they're a great way as well for you actually to go through and learn a bit more about cloud. A lot of the information I covered off today, I got out of this Azure Fundamentals course, and it's totally free to run through. So yeah, if you get a free time, again, after exams, focus on exams, then yeah, strongly recommend to go and have a bit of an investigation into this and really skill up into it. As I mentioned, it's a skill that's in demand at the moment, and it's not something you'll regret sort of delving into. So yeah, I guess I'd impart that onto you if I could choose anything. So that's really all I had in terms of content. We've got a solid 10 minutes left of Q&A if we have anything. I will do this one as well because I quite like this slide. Thank you. I love it. It's my favorite slide I've ever seen in my life. And I saw a guy do it when I was doing my training in Beijing. And I said to him, I need that. I'm putting it in every single one of my presentations. So thank you for listening. I'll pause now and see if there's any questions. So Paul, Nick, anything that's come up in the chat or that you've been pinged that you'd be curious to ask? Otherwise, if anyone wants to come up on mute, yeah, feel free to chime in and I'll answer if I can.
Yeah, we're starting to get a couple of questions in chat. So Chi Shang asks, what is a typical day like as an ML engineer?
So my role specifically is I'm a customer engineer. So customer engineer, the idea behind our role is that we're really the technical resource that gets to go on site with customers. So normally that means I get to travel a lot, which is great because I love traveling. I love planes. I'm off in New Zealand, Singapore, Thailand, all over the place. I absolutely love it. And in terms of what I do, I am the technical resource that gets assigned to customers when they're sort of in a machine learning project, as an example like that. So really it depends on what my customers that I'm dealing with are actually doing. If they're actually implementing some machine learning a project or something like that, it could just be an advisory role where I'm sort of giving them the information when it comes to the Azure and Microsoft capabilities, telling them about best practices. I might actually be sitting down with them and running them through some code. Another example, though, of at the moment, what I have been doing a lot of is some knowledge transfer sessions with customers. So they'll reach out to the account team at Microsoft assigned to them. They'll say, hey, we want someone to come in here and teach us about Azure Machine Learning. And then I go usually on site with them, but at the moment remote, obviously, and teach them about Azure Machine Learning over 3 days, as an example. And it's not just machine learning. It could be anything that I'm sort of accredited in or certified to be able to deal with. But it really depends on what my customers are doing. So a lot of it is, though, yeah, getting hands-on with the customers, which I love. I love that dynamic environment. Working with a lot of customers over a short period of time, it's been a fantastic role. So I hope that answers your question.
Thank you for that. We have another question from Andrew. Andrew asks, did you get Azure certified prior to joining Microsoft?
I didn't, Andrew. So it's something that if I had the opportunity, I would have done. UTAS doesn't really get a lot of the big companies coming down to talk, unfortunately. And if it was something that was free, I would have jumped on it as soon as I could have. But they are quite expensive. I think it's like $150 to $200 to just take the exam, and that's not even guaranteeing that you'll pass it, and you have to pay again if you don't pass it. Luckily, though, with Microsoft, they pay for us to. All of the exams are free for us to do. So at the moment, I'm sort of jumping on that and doing as many as I can. It's not something I'd stress about too much. Focus on university, focus on getting a good result, focus on getting a good CV, do some side projects if you can. I'm sure there's some, it's UNSW, you're bound to have some exciting stuff going on there. Make your CV look good. If you get the opportunity for any certifications, not just Azure, any certifications, jump on them and do them. If you've got sort of the bandwidth to be able to do it, because they are a really good example of something that you can take with you for the rest of your career, and say, hey, I know what I'm talking about when it comes to this area. So keep an eye out, I'd say.
All right, we got a question from Kai. He asked, how much code, if any, is typically written in your role?
Thank you, Kai. So I don't actually write too much code at the moment. Again, it depends on what my customers are doing. So typically, I won't write too much code. I'll actually just look at the code my customers have written. In situations where I do end up writing code, though, which is relatively uncommon, it's usually just following the generic sort of machine learning lifecycle. So I'll ingest some data, I'll transform some data, I'll feed it into a machine learning model, I'll do my training of my model and hyperparameter and parameter tuning and so on. Nothing too surprising, though. It only gets a bit more complicated when I have to sort of integrate it up with Azure in terms of sort of containerizing that code, as an example. But really, I don't do it too much. Most of my role, really all I am is mostly a consultant is probably the best way to think about what I do. Very similar to, at least. So not typically too much code, although I do love to write code. Python's my favorite language by far. Again, data scientist, so.
All right. Irvine asks, is it worth to study all technical roles, such as a data scientist, AI security, or should I focus on only one role?
Do what you find most interesting, Erevan. I mean, it depends as well, I guess, in terms of how much time you have left until you're sort of actively applying for roles. If you've got time, though, I mean, I'm the kind of person who, if I've got something I can learn from, I'm going to jump on that opportunity and use it. And all of this stuff is free, so it's not like you have to rush ahead and actually do it. So really, what I'd say is, don't be afraid not to do everything, but obviously focus on the ones you care about most. If you know you're caring about security, then just focus on the security ones for now. If you maybe are curious about AI later on, then you know that's a resource you can use later. So yeah, and again, it's just based on your bandwidth. Focus on university, though. That's, again, unfortunately, the main thing I have to impart on you. It does matter, unfortunately.
Yeah, Cressida asks, what's the worst contingency at a data center?
The worst contingency at a data center. I don't actually have too much exposure to sort of contingencies when it comes to data centers, and I'm sure they've got stuff that they aren't allowed to talk about or sort of publish. Typically, though, what you end up seeing is you get sort of distributed data stores, so something like Cosmos DB, which is our sort of distributed data store service that we have out there. This is actually a data store where you can actually fail over 2 different regions, and you have multiple copies of your data spread out over potentially the entire world. So, I mean, there are contingencies at data centers, and I mean, it's quite interesting when you read into it, actually, because they do have to actively plan for, hey, what happens if Southeast Australia gets nuked? Like, that's stuff they have to plan for. They plan for these failovers because the amount of sort of investment from like hundreds of thousands of customers into these data centers and into Azure, the stuff that's on there is really, really important data. So I can't give you sort of specifics around what the contingencies are. It's something, go ahead and have a look at it if it's out there. It'd be an interesting read. Maybe that's something I can look into more as well. A fun afternoon reading, I'd imagine.
All right. Yeah, we have time for a couple more questions. So Chi Shang asks, does Microsoft have a data center near Sydney that is publicly accessible? Just curious to see how it, yep, just curious to see how it is like.
So we have, again, we have a few data centers in Australia specifically. I think we have one in Sydney from memory, and don't quote me on that. I know we have two in Canberra. I'm not sure if you can tour them though. It'd be worth investigating because, again, it's a really, really interesting experience. They do have virtual tours that you can do at the moment as well. Obviously, there's restrictions with COVID and everything going on. But have a look into it. And I mean, even if it's not Microsoft specifically, have a look into some of the other cloud providers and see if there's any data centers you can tour there. Typically, it's very restrictive a lot of the times. And I mean, maybe that's something that you can get sort of some sponsorship from the university about. I'm not sure in terms of how responsive they'd be to that, but it'd be interesting, and I strongly recommend it. But again, they do have those virtual tours that you can just access on YouTube, I think, if you want to have a look into them as well.
Yeah, that looks like all the questions we have for now. I see a couple more people typing up something right now. So if you would you mind moding a bit more, or do you have to go right?
Are there people hired to break into data centers? I'm sure there is. I'm not sure how much success they'd have because they are very locked down. I went to one in Canberra that wasn't a Microsoft specific data center, but they're really locked down. Like huge, tall iron fences and big, scary men standing out the front. I'm sure someone's tried though. um, I'm not sure if they're hired to do it though. I mean, they probably are. I don't have too many insights into that part of society. um, awesome. I do have to drop at 4, unfortunately, Paul, Nick, and Luke. But maybe if everyone, if I'll stick around for like another 2 minutes, maybe. If you have any other questions though, maybe Paul or Nick or Luke, if they send them through to you, and if there's any common questions that you get, feel free to ping them through to me, and I can answer them in email. Otherwise, yeah, thanks everyone so much for coming along. I hope this was insightful for you. I guess if I could impart anything onto you, work hard at uni. Uni matters. Do your best. Find what drives you. Think about how you can position yourself best for sort of organizations that you might want to start to apply for. Go for an internship if there's opportunities there. Jump on any opportunity that comes through, and continue to be involved in things like this as well. Anything like this, like the CSE Society or any of the other societies that are at UNSW, are a great thing to have on your resume as well. And they're things that hiring teams specifically look for. So yeah. Show what drives you, and then people will respond well to that. But yeah, thanks everyone for coming, and I hope it was valuable for you.
Thanks so much, Joe.
Really appreciate it. Yeah, I just wanted to say a huge thank you once again for volunteering your time. And I, for one, found your workshop really interesting. I didn't really know much about cloud, but I think I've gotten a solid introductory grasp on it now, and I'm definitely really interested in it. So thanks for that.
Oh, no problem. Thanks for having me, and stay safe, everyone. Wear a mask and wash your hands. I'll stop recording now as well.
All right.
Okay.